Hello students, greeting from my side. So today I am teaching you the refraction of light through a plane surface, and in this topic I will be covering the laws of refraction. In the last video of mine I have taught you the basic idea of the refraction, the definition of refraction, and also the speed of light in the different transparent medium, about the rarer medium and denser medium. All these things I have taught you. So in this video I am teaching you the laws of refraction, and also I will be teaching you the refractive index. So now see, what do you mean by this? What is the laws of refraction? Before I should start this laws of refraction, you must have studied the laws of reflection in class 9. What is that laws of reflection? Can you say me? There are two laws of reflection. What are these? First law was the incident ray, the reflected ray, and the normal at the point of incidence all lie in the same plane. That was the first law of reflection. Whereas the second law of reflection was the angle of incidence is equal to the angle of reflection. Means in case of the reflection, what happened? The bouncing back of the ray of light that I have told you before. But in case of refraction, what happened? Transmission of the ray of light. The ray of light is going from one transparent medium to another transparent medium. But in case of reflection, what happened? If the ray of light falls on a mirror surface or highly polished surface, what happened in that situation? In that situation, the ray of light is reflecting back. But how the ray of light will reflect back? It will follow, it will obey the second law of reflection, what I told you. That is the angle of incidence is equal to the angle of reflection. That means the ray will come back in such a way that the angle of reflection has to be equal to that of the angle of incidence. So this is what about the laws of reflection. Now, what are the laws of refraction? Like reflection, there are two laws of refraction. The first law is the incident ray, the refracted ray, and the normal drawn at the point of incidence all lie in the same plane. This explanation I will be giving you afterwards. Just you see the statement of the first law of refraction. Now I will be giving you the statement of the second law of refraction. For a monochromatic light ray and for a given pair of media, the ratio of sine of angle of incidence to the sine of angle of refraction is constant. This constant is called refractive index of second medium with respect to first medium. That is sine I upon sine R is equal to mu 2 1. So the representation of the refractive index over here is mu 2 1. So what is the meaning of mu 2 1? The symbol what I have used for the refractive index is mu. In some cases it is also used as n. So here mu 2 1 stands for refractive index of second medium with respect to first medium. So here the students, they do mistakes. They don't understand what is the sine I by sine R. So here it is not only the angle of incidence divided by angle of refraction. It is the sine of angle of incidence to the sine of angle of refraction, or it is the sine of angle of incidence divided by sine of angle of refraction. So here sine is the trigonometric ratio. You must have known that. Sine, cos, tan, all these are the trigonometric ratio, isn't it? So sine is the trigonometric ratio. The sine, the value of sine we can find from the right angle triangle by using the formula, that is your what? Perpendicular divided by hypotenuse. So sine theta is equals to perpendicular divided by hypotenuse, and theta over here acute angle. So this sine we are using over here. This is sine I upon sine R is equal to mu 2 1. So here mu 2 is written in the right hand side and 1 is written in the left hand side. This means that we are going to find the refractive index of second medium, the things which is present in the right hand side. We are going to find the refractive index of that medium with respect to the first. means from where the ray of light is coming. How you understand which one is the first medium, which one is the second medium? You will be getting the incident ray, then you will be getting the refracted ray. Obviously, the incident ray will be there in the first medium and refracted ray will be there in the second medium. So in this way, we will find the refractive index of second medium with respect to the first medium. So now let's see what is this first law says that. I'll be explaining you about the first law. So I repeat again, the first law of refraction says that the incident ray, the refracted ray and the normal drawn at the point of incidence all lie in the same plane. What is the meaning of this? All lie in the same plane. Just understand this from this diagram. One diagram you can see over there. See, one incident ray is coming. Are you seeing here? This is the incident ray which is striking over here, and this is the refracted ray which is coming in the second medium. Here the medium, two mediums are there. This is medium 1, medium 1 is air. Then this is your medium 2, medium 2 is glass. You can see over there is written over there, and this is your incident ray. Incident ray is here. It is striking at this point. After that, it is refracting along this direction. This is therefore written refracted ray. This is the normal, dotted line is the normal, and this is your angle of incidence. I is the angle of incidence and R is the angle of refraction. Before I have told you also that when the ray of light moves from air to the glass medium, how does it bend? It bends towards the normal. Are you seeing that the ray is bending towards the normal? Because this is the actual path of the light ray. It is not moving in the actual direction of this, and due to presence of the glass for the second medium, the ray is moving towards the normal. So this is the refracted ray. So here if you see this incident ray, refracted ray and the normal, all these three things are present in one plane. Now what is the meaning of plane over here? The students, they confused, they don't understand what is the meaning of plane over there. Plane means here you are doing, if this diagram is drawn on the on a board, then it remains on the plane of the board. Everything will remain over there only. If you do this diagram, if you draw this diagram in your copy, then the plane of the incident ray, refracted ray and normal will be on your copy itself. So this is what we say, the plane. This is the meaning of the plane. So next I am explaining you about the second law of refraction. Now what is the second law of refraction? Says that the ratio of the sine of angle of incidence divided by sine of angle of refraction is equal to constant, and that constant is the refractive index of the second medium with respect to the first medium. Now see over there in this diagram, it is shown one diagram over here. This is medium 1, this is your medium 2, medium 1 is air, you can see over there, and medium 2 is glass. Are you seeing this? And this is the incident ray, this is the refracted ray. Here the angle of incidence is 30 degree and angle of refraction is 19.3 degree. Are you seeing this is? So let's find that refractive index of this glass with respect to air. Now see the second diagram. You can see the second diagram over here. In the second diagram, what is shown there? Just see in the second diagram. This is the incident ray. This is the refracted ray. It is here also same things I have given. Medium 1 and medium 2. Medium 1 is your air and medium 2 is the glass. And here the angle of incidence is changed. Over there you can see the angle of incidence is 45 degree, whereas the angle of refraction is coming 27 degree. Why? Because the ray is bending towards the normal. Therefore the angle of refraction is becoming less than that of the angle of incidence. All right. Now see in the third diagram. In this what happened? The angle of incidence, see over there, this is the angle of incidence, that is 60 degree, and this is the angle of refraction, that is 34.9 degree, which is shown over there. And this is your medium 1, same medium, that is air, and that is medium 2, glass. Here I have changed the angle of incidence and angle of refraction. Now see, compare in all these three diagrams. What you are seeing? The angle of incidence are changed, and due to that the angle of refraction are also changed. So now here we'll find how much will be the refractive index of the glass here, which is the second medium. Glass is the second medium, and which one is the first medium? Air is the first medium. So now we see what is the value of the refractive index of glass with respect to air. So now see one tabulation for you to find the refractive index. See there nicely. This is first diagram we have taken. First diagram, angle of incidence is 30. So it is written over there. Angle of incidence 30. And this is your angle of refraction, that is 19.3. So here when you find the ratio, that is sin I divided by sin R, that is your refractive index of the second medium with respect to the first medium, means the refractive index of glass. Here the second medium is what? Glass. So here it is coming 1.5. See in the second diagram, angle of incidence is 45 degree. You can see over there, angle of incidence 45 degree. So it is written over there. And angle of refraction is 27.9 degree. And therefore sin I by sin R is coming 1.5. And then in the third diagram, the angle of incidence is 60 degree, angle of refraction is 34.9 degree, and the value is coming 1.5. Approximately equal to, it will be coming 1.5 in all these cases. So whenever you calculate this value with the help of the calculator, you will be finding 1.5, which means that the refractive index of the glass with respect to air is 1.5, which is giving us a constant value. Whatever angle you take, maybe you change the angle of incidence, any angle of incidence you are taking, and accordingly the angle of refraction will change, and the value always remains 1.5. Therefore I have told you, for a monochromatic light ray, what is the meaning of monochromatic light ray? For a light of single color, one color light it should be. Here you can see over there I have given one blue color light. For a single color light, the the ratio of the sin of angle of incidence to the sin of angle of refraction is constant for a given pair of media. Again, what is the meaning of this given pair of media? Here two media are there. Medium 1 is your air and medium 2 is your glass. So that means when the ray of light is coming from air to glass, every time you find the refractive index will be 1.5. Again, if you change the medium, suppose you are bringing the ray of light from say air to water, so at that moment again it will be changed. Here it will be not same as this 1.5, maybe some other value will come. When the ray of light is coming from air to the water, the refractive index of the water with respect to air will be 1.33. So here it will be 1.5. So therefore I have told you, for a given pair of media, remember this. It is means for the same things what we are doing. We cannot compare this glass again with the water. If we say, sir, this is air to water, it is coming 1.3. But it's air to glass, it is coming 1.5. Yes, for air to glass, every time it remains 1.5. For this type of medium, again also the density of glass may be changed, and due to that refractive index may also change. But for this given situation, you are getting as 1.5. So therefore, I have told you, for a monochromatic light ray, for a given pair of media, the ratio of the sin of angle of incidence to the sin of angle of refraction is a constant, and that is your 1.5. So students, just you see over there, here the ray of light is coming from rarer to denser. In all these cases I have given there, the ray is coming from rarer to the denser medium. Now when the ray of light comes from rarer to denser medium, how it is moving? It is bending towards the normal, that I have told you before. If suppose the ray will come from glass to air, then what will happen? In that situation, the ray of light will be not bending towards the normal. Rather, the ray of light is bending away from the normal. Video, you must have seen that. I have given the lecture over there. The bending of the ray of light, when the ray of light moves from rarer to the denser medium. Again, when the ray of light is moving from denser to the rarer medium, how it is bending. that I have told you, and you have seen that one. Now I am showing you in the practical way how the ray of light is bending while it's coming from rarer to the denser medium, again when it's moving from denser to the rarer medium. Just see here, students, I have chosen here two medium. You can see here two media. One is your air, this is your air medium, and this is your glass medium. Just you can see here, this is the glass medium. Say now a ray of light falls on the interface separating two media. How the ray of light is bending? Just have a look. Suppose a ray of light is falling like this. Red color light is falling. I have told you monochromatic ray of light should fall. Now when the red color is falling over there, you see some of the ray of light is reflecting along this direction, some of the ray of light is refracting. Now and here you see the ray of light is bending towards the normal. Just see here this is the actual path of the light ray, but it is not moving along the direction of the actual path, rather it is bending towards the normal. This is the normal which is drawn at this point of incidence. This is your incident ray, you can see this, and this is your refracted ray, you can see this, and this is your reflected ray, partial reflected ray. I have told you during the course of the refraction, partial reflection is also taking place. We cannot say that reflection is not taking place. Partial reflection is taking place, but here the intensity of this light is very less, and due to this reflected ray, the intensity of the refracted light is decreasing. Here you can understand how the intensity of the refracted light will be decreasing. I will show you, but before that, just you see here, here suppose I'll change the angle. Now what happen if I change the angle? Just have a look here, this angle is given here 45 degree. Now I'll change the angle. Now I'm making it say 61.8 degree. So here when the angle of incidence is 61.8 degree, angle of refraction is becoming 36.0 degree. That means it is becoming 36, which is less than the angle of incidence. Why it is less than? Because you know that the ray of light has to bend towards the normal. So when the ray of light, or that is the refracted light, is bending towards the normal, obviously the angle of refraction will be less than that of the angle of incidence. But see here, the angle of reflection is same as that of the angle of incidence. That is how much? 61.8 degree. So this is your incident ray, this is your refracted ray, and this is the normal. So here the ray of light is going from air to the glass. That means from the rarer medium to the denser medium. Now in this situation, if the ray of light falls normally, what happens? Just have a look. Suppose the ray of light is falling like this normally, perpendicularly onto the surface. So when the ray is, wait 1 minute, when the ray is falling normally here, yes, when the ray of light is falling normally onto the surface, the angle of incidence is becoming how much? You can see here 0 degree. Angle of refraction is becoming 0 degree, and angle of reflection is also becoming 0 degree. Therefore the angle of deviation will be how much? There will be no deviation of the path of light ray. Therefore the angle of deviation is also 0 degree. So angle of incidence is 0, angle of refraction is 0, and angle of deviation is also 0 degree. So now I'll change the medium here. Here suppose we have taken which medium now? Air to glass it was coming. Now we'll take say from glass to air. That means from the denser medium to the rarer medium. Then what happened? When the ray of light is coming from denser to rarer medium, we have known that what happened? The ray will move away from the normal. Just see what is happening. This medium I will be changing. This is I am making it a glass, and this is I am making air. This medium become air. This is the second medium, and this is the first medium. First medium become here glass, and the second medium become the air. Now say a ray of light is falling over there. See, when the ray of light is falling over here, the angle of incidence is 23.9 degree, whereas the angle of refraction is becoming how much? 37.4 degree. That means the angle of refraction is more than that of the angle of incidence. Now why? Because the ray of light is bending away from the normal. It is moving away from the normal. This is the incident ray. If there will be no interface, if the ray is supposed to go straight, then the ray will move along this direction. This is the direction. This is supposed to be the direction of the incident ray, but it is not moving along this direction. Rather, it is going away from the normal. This is the normal. It is moving away from the normal. So therefore, when the ray of light falls from or moves from denser to the rarer medium, it moves away from the normal. So here, if you make it fall normally, when the ray of light falls normally, just see, when the ray of light is falling normally, it is going from glass to the air. How the ray of light is moving in the second medium? It is moving straight. There would be no deviation of the path of light ray. Therefore, the angle of incidence is becoming 0, the angle of reflection is becoming 0, and the angle of deviation is also becoming 0, angle of refraction is 0. So all these are becoming 0. Here you can change the color of the light, because I have told you the monochromatic light ray. Now here, suppose now I am changing the different colors. Just see, say I am changing now blue light here. See now, so this is also, it is remaining blue. There will be no change of the color. Now I will use green light. These are the monochromatic light ray, means light ray of single color. That is known as the monochromatic light ray. So this is the green color which is falling, and then the green light is also coming. Therefore, when the monochromatic light ray falls on a surface, and if it is coming from one medium to another medium, while it strikes on the surface separating the two media, then what happens? The refraction will be taking place. But when the ray of light falls normally, going from any medium to any medium, then there will be no refraction. The ray of light moves undeviated. Say for example, now in this case, this is the glass medium. Now if the second medium will be chosen glass, what happens? Just see. Now second medium I will choose as glass. See what is happening here. Here the ray of light is moving. See what is happening to the ray of light is moving undeviated. There would be no bending of the ray of light. Why? Because the speed of light in both the medium will be same. Therefore, there will be no deviation of the path of light ray. Now, if you change again, then there will be the deviation of the path of light ray. Suppose the first medium now I am making air, and the second medium I am making it glass. Now I am changing the angle of incidence over here. Just see, if the angle of incidence is changed, what happens? Accordingly, the angle of refraction is also changing. Are you seeing that? It is now 53.8 and it is given here 32.6 degree. So when the angle of incidence is changing, angle of refraction is also changing. Now let's measure the intensity. Here intensity is 100%. Now see, the intensity of the refracted ray is becoming here 77.69%. Now measure the intensity of the reflected ray. It is becoming 22.31%. So because some of the intensity of the ray of light is there in the incident ray, therefore in the reflected ray, therefore the intensity of the ray of light in the refracted ray is less than that of the incident ray. So this is how you will do in the experimental way to find the intensity and all. Now see, if you want to measure the speed, see over there, I am measuring the speed for you. This is in the air medium, therefore the speed is showing how much there, 1c. Now let's see the speed in this medium, how much is becoming. Speed, this is in the glass medium, speed in the glass medium, it is becoming 0.67c. That means less than that of the speed of the light in the air. In the air, the speed of light is 3 into 10 to the power 8 meter per second, whereas the speed of light in the glass will be 2 into 10 to the power 8 meter per second. But if we measure the speed of the reflected ray, how much it is coming, just see, it is same as that of this one, incident ray. Why? It is also in the air. So next I'll discuss the refractive index. Now what is refractive index? refractive index of second medium with respect to first medium is defined as the ratio of speed of light in the first medium to the speed of light in the second medium. Another definition of the refractive index. The refractive index, you have known that from the Snell's law of refraction, that is the second law of refraction. The second law of refraction is known as the Snell's law of refraction. From there you know that is one definition of the refractive index. Now this is actually the refractive index is expressed in terms of the speed of light. So this is the true definition of the refractive index. So therefore refractive index is defined as the ratio of the speed of light in the first medium to the speed of light in the second medium. Say for example, if the ray of light is coming from air to glass, that means in order to find the refractive index of the glass, what do you have to do? So refractive index of the glass is equals to speed of light in the air divided by speed of light in the glass, isn't it? If suppose the ray of light is coming from any medium to any medium, say it is coming from glass to diamond, that means in order to find the refractive index of diamond with respect to glass, there will be not getting diamond with respect to air, because the ray of light is coming from the glass to the diamond. Therefore the refractive index of the refractive index of diamond with respect to glass, that is speed of light in the first medium, that is what, glass, divided by the speed of light in the second medium. Just see here, the formula is written mu21 is equals to speed of light in the first medium divided by the speed of light in the second medium. Therefore mu21 is equals to v1 by v2. So next, this is when the first medium becomes vacuum, then the refractive index of the second medium is known as absolute refractive index. Remember here, when the first medium becomes vacuum or air, in some cases we consider air also. So in that situation, the refractive index is known as absolute refractive index. Therefore, how can you define the absolute refractive index? Absolute refractive index, here see, the expression is written mu is equals to C upon V. Here C stands for what? The speed of light in the vacuum or in the air, and V stands for the speed of light in that medium in which the ray of light is going. So in order to define this absolute refractive index, you may write this is the ratio of the speed of light in air to the speed of light in the medium, because any medium we are taking. So here in this expression you can see I have used the formula, that is mu is equals to C by V, where C is the speed of light in the vacuum. The value of C you know, that is 3 into 10 to the power 8 meter per second, and the V is the speed of light in the second medium. So now see, we will determine the refractive index of a medium. How can you determine the refractive index of the medium? We can determine the refractive index of the medium by using that formula. Which formula? The speed of light in the first medium divided by speed of light in the second medium. Or we will use the formula refractive index mu is equals to C upon V, provided the value of C you should be knowing and the value of V you should be knowing. Then only you can find the refractive index of the second medium with respect to first medium. Here one example I have given for you. See, in this example, a ray is traveling from air to the glass. So when the ray is traveling from air to the glass, we will have to find the refractive index of glass with respect to air, and the speed of light in the air is 3 into 10 to the power 8 meter per second. The speed of light in the glass is 2 into 10 to the power 8 meter per second. So now we will have to find the refractive index of glass with respect to air. So now I see, so mu glass, and in the left hand side we write what? Air. So mu glass with respect to air is equal to C upon Vg. Here Vg stands for the speed of light in the glass. The speed of light in the air is how much? 3 into 10 to the power 8 meter per second. And the speed of light in the glass is how much? 2 into 10 to the power 8. Now whenever you simplify this, 10 to the power 8, 10 to the power 8 will cancel, and this is 3 by 2. So 3 by 2 is how much? 1.5. Here there will be no unit of this. Why? Because it is a ratio of two same quantities. Speed means the ratio of the speed of light divided by the speed of light in the air divided by the speed of light in the glass. That is what we are doing. So therefore it has got no unit. There is no unit for refractive index. Question may ask you, what is the SI unit of refractive index? Then in that situation you write, there is no unit of refractive index. It is pure number. One numerical value you will get, like 1.5, anything, any value you will be getting. Now we'll see another example. In this, see there, the ray is traveling from air to water. In the first example I have given, the ray was traveling from air to glass. Here the ray is traveling from air to water. See there, this is the air medium. Medium 1 is the air and medium 2 is the water. The ray is coming from air to the water here. The speed of light in the air will be 3 into 10 to the power 8 meter per second, and the speed of light in the water is 2.25 into 10 to the power 8 meter per second. This is the value which is given to us. Now we need to find the refractive index of water with respect to air. Now we'll find same formula you use over there. That is what? Mu water with respect to air is equal to C upon BW. So C stands for the speed of light in the air. So the value, just you write down the value of this, 3 into 10 to the power 8 divided by 2.25 into 10 to the power 8. Why? Because the speed of light in the water is 2.25 into 10 to the power 8. So simplifying this, we are getting 1.33. So therefore, the refractive index of water with respect to air is 1.33. Now, sometimes in the question, the speed of light in the air would be given, the refractive index of a medium will be given. The question would ask you to find the speed of light in that medium in which the refractive index is already given. So you use the same formula. That is what? Mu is equals to C by B. This is what I have given you before. So in that, mu is given, you put the value of mu and then put the value of C and find the value of V. V will be the speed of light in that medium. So in this way, you can find the refractive index of the different medium, and also you can find the speed of light in the different medium. Okay, thank you.